Hey everyone! So in today's tutorial we'll be going through a couple of methods I've been exploring to get to this bold geometric 2D anime effects Toon-like visual that we see in the bottom right hand corner, made up of only a few nodes in a pop network to create this randomized lightning bolt flame. I think this works in both motion, and if we pause TouchDesigner and go through frame by frame, we can see that it also doubles as a really interesting shape generator, creating these bold geometric visuals. After we've created that, we'll look at the top composition here. And we take some of these ideas a little bit further where we work with multiple geometries, still very simple randomized pop networks. And we can build this up with several, isolating them with specific chroma masks, and then introducing a 3D fisheye camera and looking at some camera settings that will allow us to do a fly through of these and start exploring some ways that we can get some exaggerated geometric flat gradients. What's exciting about this is the technique is pretty limitless, where it's a little bit of basic understanding of TouchDesigner to get here, but the way that you customize this, the shapes that you use, and how you introduce these is really open-ended. I think it's a really exciting springboard. So hopefully by the end of this, we'll be able to get you to something that looks similar to this, that can be used in many different contexts and with many different outcomes. When we step out of it for a moment and look at the pool of influences that has led to this and what motivates me, I think of the Toon style shading in Jet Set Radio Future in contrast against these hyper dynamic backgrounds. That visual was continued further with Bomb Rush Cyberfunk a few years ago that clearly display this smart use of low poly geometry to get these cool flattened effects. Beyond that style as well, I think of the look of video games like Sable and this one forthcoming that I just came across the other day, Calyx, that has this Mobius style of fine line work with gradient flattening to it that gives it this slight amount of depth. Taking a lot of inspiration from anime fight scenes and Sakuga, the use of exaggeration and color and contrast with these flattened effects looks to them is simply stunning. I think of the animated series Scavenger's Reign and how that also continued that Mobius style of gradient shading. So it's sort of finding a fit between all of these while also taking influence from professional 2D artists like Jacob Topin, Light Soul FX, and Guillaume 2D, who are all professional 2D animators. Let's get started by taking a look at what we're working towards first. We can see down the bottom here is the render, and up the top is a geometry viewer of what I have going on. So the way that I came up with this was producing a render from a pop-based geometry to get the flattened effects look, colorizing that with a ramp and an edge top, and then putting a background over it. Relatively simple. But within here is the idea that we're going for. We're using geometry and constant materials to produce flattened renders of our scene that we can then use as masks to colorize and build the scene back together. So the way that we get to this geometry is we start with a single line node. We run that single line through a noise twice, one of them slightly larger than the other, to then merge them and skin it back. So we see that we have this ribbon of low poly geometry that is changing up every frame with the noise, but it remains connected. And with that, extracting some of the faces from it to get these detached accents, we use a delete, increase the size slightly, merge them back, and that's how we get our ribbon. So let's start it from scratch. So in a new project, we'll create a base where we can make our first ribbon effect. I'll call this fx_01 and we'll dive into this. We first start with a line pop and we'll change the point location so that it is 0, 0 on the X, 0, 1 on the Y, and 0, 0 on the Z. It's just straight up the Y axis in the positive direction. From here, we can plug it into a noise and start to take a look at what that noise is doing to our shape. So when I look at this, you can produce some really fun shapes with this, but it applies an equal amount of noise at every point. And In this example, I want to taper the line so it starts smaller at the base and expands to the middle. So I thought an easy way to do that was we could look at the noise amplitude, but we could map the Y height to the amplitude. So the higher up you are in the line, the greater the amplitude is. So if we insert between those a math, and we take the Y height, which in this case is P1, I want to output this as a new attribute, and I'll call this amp multi. So now with this amp multi attribute, when I use the multiply parameter, that will scale the level of influence. So under our noise pop, when we go to map and we look for the particular element amp multi, we can map those numbers onto our amplitude parameter in our noise. So now what happens is the Y value corresponds to the magnitude of the noise. We see it's getting greater as we go up. And then if we take the math operator that we added to there and we play with the multiplier here, we're able to apply a slight taper where it affects greater at the top. This taper could be achieved in many ways. I'm sure you could create a ramp top and then map the black to white values into a pop operator and then onto this. That would work just fine too. So with that noise, we're taking this and we're duplicating it. So we have two examples of it, and we want to merge these back together with a merge pop. So with these two being identical, I wanted to create something that differentiated them, that wasn't simply shifting it around. So we can add a math operator in between the first math and the second. Rather than doing a multiplier on the position, if we get the amp multi again and we use this multiplier here, it will maintain the same shape as its top one, but only slightly provide a sort of subscale increase in the way that the noise is being applied. What this does is you get this coherence between both lines as they're trying to merge. So when we apply a skin operator to this and change the viewport to wireframe, we see that we get what is quite a nice tiled paneling of this ribbon, this very low poly geometry ribbon. So with that there, that's enough for us to put it into a geometry and start shading it. So we add a geometry into the network, also adding a camera. In this example, we'll just use a standard perspective camera and a render top. Let's change the render to a square-based image, 1500 by 1500. I'm going to put that into a null, and I'll make this visible. So I'll split my network viewport up with Alt open bracket. I'll change the right panel to be a top viewer, sizing that back across. If I make this null visible and I drag that into the top viewer here, I can right click on my background and take the visibility off so it only displays on my right hand side. Let's now create a constant material and keep it as white so that we can see what we're working with. And I'll scoop my camera up by 0.5, so it's in the center, and I'll take the Z axis into 2.5. Now, as we apply the noise, animating at different axes will achieve a different look. For this demonstration, I found that decreasing the Y value starts to make it look like this is being produced from a single point and that there is an airflow pushing it upward. There's continuity on the Y axis, so with a descending Y value, we get that smoke ribbon look. So to drive that, it's not fantastic practice, but we'll start with a speed chop and we'll make the speed a negative number. So if we start with negative 0.5, this value will now continue to decrease at this rate in the negative direction. So if I put that into a null and I make that null active, I can group select both noise and drag this into their Y parameter. So this should reference on both. We can see our connective arrows. So now it looks like it is continuing to ascend. Now with this ascending, we do get quite a smooth look to it, and it does expose some of the volatile characters of working in low poly, which is not to our taste, but can be interpreted in many ways. If we were to increase the division count, that would give us far more to work with, and we get this almost calligraphy, Toon-like smoke trail. I'm going back down to 20 divisions because I want a slightly more sort of punchy geometry to it. The next step here is about how the image is exposed and interpolated. In 2D animation at a 24 frames per second frame rate, you would normally be watching animation exposed on 2s, that is the drawing holds for 2 frames. Some slower action is on 3s, some fast action is on 1s. But with the way that TouchDesigner naturally animates this at 60 FPS, but I almost want to go in the opposite direction of what TouchDesigner is trying to achieve, which is a 60 FPS smooth real time. So I was thinking we could add a cache afterwards, reducing the cache size to 1 and increasing the step size to maybe something like 4. So it jitters far more and it pauses, it holds each frame for 4 counts. But this is a bit excessive because we're still rendering at 60 FPS and just stepping through the cache. So rather than doing it after the render, I thought of adding a limit to the speed, which would create this stepped motion. So rather than the smooth number passing through, we go limit, we go over to the quantize page, we turn rounding quantize value on. And now what we see is that the number doesn't step through all of these smaller decimals. The noise doesn't increase, it's now stepped, and that stepping is maintaining the motion but reducing the number of exposures. So we can play with the stepped value that it rounds to. Reducing it would make it smoother, increasing it would give us a very blocky, steppy look. So this is another variable or parameter that you can play with depending on the look that you want. Let's take this to a rounded value of 0.5 and let's increase the speed to -5. And it's with these two values that we get the tutorial. So while this was really fun and cool, I also thought that we could use some of the points within the network to create these fractured splatters that stay, again, coherent to the randomized geometry, but they're always just a little bit of an extension further to create a more broken up look. We can do this easily after our skin operator. I'll give us a little bit more space. So if I branch off from here by middle mouse clicking and going to delete, when I head over to the thin page, I'll activate this and go into here. When I increase the thin random parameter, what we start to get are these fractures of the network that we're working with. So if I made this viewer active, press W for wireframe, we see that it's essentially deleting a number of faces within the network already. Decreasing it will bring it back to a whole. Increasing it, it doesn't have many faces to work with, will give us far less. I'll take this down to a thin random of 0.3, which gives us a handful, looks like 4 faces in our ribbon. Now these are sitting in the exact same spot as our ribbon, so we could add a math to this, increase the multiply by something like 1.5 so that they're expanding outward from where it is sitting on the outside. And if we add a merge in between this math and this skin, it will bring those geometries back together, but not connect them. So now we can see that I'm getting this fractured line that kind of dances coherently within our little lightning bolt. Some strong looks. Already there's so much that you can play with here. The way that the noise is randomized, the way that it's applied to it, if you're stepping the motion, if you're using other fractured fragments to it, or if you're taking these dots and then adding that to a copy network where it's bringing a new geometry entirely into the network. I think it's a pretty effective single technique that's quite easy to comprehend. And from here, this is where we start to do this post-processing that brings the gradients into it. So in this case, I don't need to isolate anything because I've only got one subject. So with this coming out as a white, I'll change this to 32-bit float just so I have more to play with. And I'll introduce a ramp top into here. Change the type to vertical. And with this ramp, I can use this to colorize the fill of our animated geometry. So something darker at the bottom, go for a much lighter color at the top, this kind of sunset gradient look to it. Introducing an edge top to this to get that outline. and making sure in the output page that we have composite edge with input. So we can come up with do a blue line and then simply add a background color to this with a transform top. Making sure the background color alpha is set to 1 so it's visible, and we turn that toggle on. So now when I control the color. So yeah, it's a few simple operators to create this look. It's very much a reverse engineered look where I'm sure there are better ways to get a line out of a 3D render. But for a warm-up, it works good. So with our more advanced take on this, we have a geometry scene where there are multiple different randomized geometries, and that's being taken in by a fisheye camera. Working with the fisheye gives us a lot of really cool stretched results. There are some downsides to it, but I'm really happy with how it finishes the scene. So we take that idea and we just expand on it slightly. There are a number of different geometries that are color-coded into the render, so that makes it easy to isolate them after the fact. Taking each one out with the chroma key, so we're able to apply a gradient to it individually and then comping them all back together. Using an edge as a line technique, we get something pretty effective with a logic that I think is quite accessible. I've made use of a camera blend in this situation as well, so that on my key trigger, I'm blending between these different perspectives. And that too is creating this fun kind of exaggerated randomness as each camera interpolates its position. And then with the rest of it, it really was just playing with different geometry types. These one I have on a key trigger as well. I could easily see this being controlled by something audio reactive, as well as the camera position. And then as you start to build out the scene and play around with it, you're going to get some really fun shapes. So these really do exist as just geometries with their own respective pop network. Relatively simple. We start with a basic shape. We run it through some type of noise and randomness that gives it a dynamic quality. We have this case where we break off and create particles with existing points. This will take a little bit longer, but it's quite fun. And then on the top level, I've isolated the render of the geometries to kind of interchange between what I have. So in combination with the randomness of the noise, the camera, and the geometries, we get some pretty fun stuff.